before going to the next question, I would like to tell you the concept on which the next question is based. That is to find the points where the electric intensity is 0 with respect to a given charge configuration. Remember, in CET, charge configuration will consist of only two charges. Suppose Q1 is one charge, Q2 is another charge. You want to find out the points where the electric intensity is 0. Remember one thing, above the line joining the two charges and below the line joining the two charges, the two intensity vectors will be inclined at an angle other than 180 degrees. You know that resultant vector of two vectors will be 0 only when the two vectors are equal and opposite. That is, angle between the two vectors is 180 degrees. Since angle can never be 180 degrees either at any point above the line joining the charges or below the line joining the charges, the points of 0 intensity must lie along the line joining the two charges. This is a minimum requirement. Along the line joining the two charges, I identify three positions. One is between Q1 and Q2, other is to the left of Q1, third is to the right of Q2. Suppose Q1 and Q2 are both of the same nature, in the sense either both positive or both negative. If you consider a point in between and place a unit positive charge, Q1 will repel, Q2 will repel. Hence the angle between them can be 180 degrees. If you consider a point here, Q1 will repel, Q2 will repel. Both are in the same direction. Resultant can never be 0. If you consider a point to the right of Q2, once again Q2 will repel, Q1 will also repel. The resultant intensity can never be 0. By this, we come to a conclusion that when the two charges are of the same nature, the electric intensity can be 0 only at a point between the two charges along the line joining them. Let me now assume that Q1 is positive and Q2 is negative. In that case, if you consider a point in between them, Q1 will repel, Q2 will attract. Two forces are in the same direction, therefore the resultant cannot be 0. But if you consider a point over here, Q1 will repel, Q2 will attract, therefore the two forces are in the opposite directions, hence the resultant can be 0. By this discussion, we come to one shortcut information that when the two charges are of the same nature, null point must lie along the line joining the two charges and between the two charges. But when the charges are of opposite nature, the null point must be either to the left of Q1 or to the right of Q2. Then remember, both are not possible. Electric intensity due to a larger charge at a greater distance can be equal to the electric intensity due to a smaller charge at a lesser distance. Hence, the point of 0 intensity must be necessarily closer to the smaller charge. Therefore, please keep in your mind these 3 points. Number 1, if the charges are of the same nature, null point must lie between the two charges. 2, if the charges are of opposite nature, whether this is positive, this is negative, this is negative, this is positive, the electric intensity can be 0 only at a point beyond the line joining the two charges. In the sense, either to the left of Q1 or to the right of Q2. But among these 2 points, you should choose a point which is closer to the smaller of the 2 charges. With this idea to guide us, I will take one question to illustrate the idea that I have told you. I will read the question. 2 point charges of magnitude 4 microcoulomb and minus 9 microcoulomb are 0.5 meter apart. The electric intensity is 0 at a distance x meter from A and y meter from B. X and y are respectively, first option 0.5 meter and 1 meter, second option 1 meter and 1.5 meter, third option 2 meter and 1.5 meter, fourth option 1.5 meter and 2 meter. Note one thing over here, that in this case Q1 is equal to plus 4 microcoulomb and Q2 is equal to minus 9 microcoulomb. Therefore, the 2 charges are of opposite nature. From what I told you just now during the explanation, the null point must be beyond the line joining the 2 charges and closer to the smaller of the 2 charges, means the null point must be somewhere here. Suppose it is at a distance x from A and y from B, then y must be equal to x plus 0.5, that is 0.5 plus x. If the resultant intensity should be 0 over here, the intensities due to the 2 charges should be numerically equal. Therefore, K, I am calculating the intensity here due to the charge at A, K into 4 microcoulomb, 4 into 10 raised to minus 6 divided by the distance is x, that is x square. This must be equal to intensity due to the other one. It must be K into 9 into 10 to the power minus 6 divided by square of the distance is 0.5 plus x bracket square. Please note, y is equal to 0.5 plus x. If you take this precaution regarding the positions, while taking a root, plus or minus need not be put. Then k will cancel with this k, 10 raised to minus 6 with 10 raised to minus 6. 2 divided by x is equal to 3 divided by 0.5 plus x. Cross multiplying, 2 into 0.5 is equal to 1 plus 2x is equal to 3 into x is equal to 3x. It will give you x equal to 1 meter. If x is equal to 1 meter, y is 0.5 plus 1 equal to 1.5. Therefore, the answer is 1 meter and 1.5 meter. Therefore, second option is correct.